Have you ever wondered how atoms form bonds? Or how they decide to bond, or how many bonds they can form? Oh, don't worry. It all lies with one powerful concept, which is called valency. What is valency? Valency simply is the combining power of an element. The combining power. Now, elements go into combination for one reason, because they are unstable and they are trying to attain the noble gas configuration, which is the octet configuration, whereby you have 8 electrons in the outermost shell or 2 electrons in the outermost shell. So a stable structure, either the octet structure or the duplex structure. So it's in an attempt to attain any of these state that they go into bonding because they want to be stable. And they can do this either by what? Losing electron, gaining electron, or sharing electron. When you lose electrons, remember in a neutral atom, the number of protons is always equal to the number of electrons. So if your atomic number is 1, it means you have 1 proton, 1 electron. Your atomic number is 10, you have 10 protons, 10 electrons. Now, when you lose electron in a neutral system, it means the number of protons will become more than the number of what? Electrons. And remember, your proton is positively charged and your electron is negatively charged. So that when one proton, and when you lose an electron, the number of proton is more, so now you become positively charged. That's why you see in a system whereby majorly metals, when they lose electrons, they see a positive sign in front of the oxidation number. When you gain electron, it means the number of electrons you have now will be in excess of the proton. And electrons are negatively charged, so we always give a minus sign to your oxidation number. Are you following now? So you should understand where these signs are coming from. Now, let's look at the types of valency. We have 2 major types of valency. Now, one is electrovalency and covalency. I've discussed these 2 in detail in my page. I'll be leaving the links in the comment section. Please follow them so that you can have a good understanding of electrovalency or covalency. Now, in electrovalency, what happened? It involved the transfer of electrons. So we have electron loss and what? Electron gain. So when one is transferring electron, that is majorly electron loss and electron gain. When one is transferring electron, another one is what? Gaining electron. Majorly, metals do the donation, that is, they lose electron, while non-metals gain electron. So for example, sodium can react with chlorine to form sodium chloride. This is your metal and this is your non-metal. Are you following? Your metal forms sodium chloride. This is what? This is what is formed. This is what is formed. Why covalency involve what? The sharing of electrons. So 2 atoms that are not stable will bring their atom together, their electrons together, so that they can attain the octet what? Configuration by what? Sharing those electrons. Check the comment section. I'll leave the link there for electrovalency and covalency so that you can study them properly and understand. You understand now? So example of covalent compound, for example, hydrogen molecule. Hydrogen, one electron, that is 1 hydrogen combines with the other one electron to form hydrogen molecule. Now you can see that both of them have shared their only electron, and then they have attained the duplex structure. That is 2 electrons in the outermost shell, and they are both what? Stable. And this is how hydrogen molecule is being formed. Are you following? So now, how do you know the valency of your elements? Majorly, most elements exhibit the valency as the number of group they fall under. If you're in group 1, your valency is 1. If you're in group 2, your valency is +2. Group 1 + 1, group 2 + 2. Now, when you go to the non-metals, group 7 is -1, while group 6 -2, and so on and so forth. Now, some elements. So, for example, sodium has oxidation number of +1, magnesium +2, oxygen -2, chlorine -1. These are the oxidation number. But some elements exhibit variable oxidation state. For example, we have iron, the oxidation state of +2 and +3. We have copper, the exhibit oxidation state of what? +1 and 2. This is because they can form variable compound. For example, iron can form iron chloride, iron 2 chloride, and what? Iron 3 chloride because of this variable oxidation state. Are you following us? Now, valency helps us in writing the formula of compounds. From non-valency of elements, you will be able to write the formula of a given compound. For example, if I give you element A with valency of X, element A, valency of X reacting with element B, valency of Y, the formula of the compound it will form is this Y, you bring it down here for A. So now the formula that will form is going to be AY. The Y will come down. They will exchange this superscript as now subscript. No, this will come down AY BX. So that if I have magnesium 2 plus reacting with chlorine minus, the formula of the compound will form the what? Magnesium. This one here will come down, then this 2, you exchange the 2, MCl2. So valency, the concept of valency is very important in chemistry because it helps us in a lot of things. It helps us in writing formula of compounds. It helps us in determining the kind of reaction or the kind of bonding an element will go into, and so on and so forth. Find this helpful. Give us a follow, like, share, and comment.